This video will show a few applications and a few examples. In general, it's important to understand heat, air and moisture transfer in order to get sustainable, well-performing, healthy buildings. However, sometimes it can go wrong, but it's something to learn from. The examples we are going to show is hydrothermal risk, mold growth, cold attics, slab on ground, crawl space, and lastly, how to design the building envelope. These are some quite beautiful pictures about that we can look at mold with a microscope. However, this is not really something we would like to have in our buildings due to health reasons. Mold growth. To the left we see 3 pieces of wood that have been stored in different environments around 20 to 25 degrees C and 75, 85 to 95% relative humidity. And we see clearly that if we go below 85, we are coming closer to 70%. There is less severe mold growth on the wood. To the right-hand side, we see a wall that had been damaged, been opened from the outside and looked into the construction afterwards, and we see mold formation on the joists there. There has been quite a lot of research on mold growth, and one example is the Viitanen from Finland, showing how mold is established and growing. And here are some graphs showing how fast or how big the risk is for mold growth. On the horizontal axis we have the temperature, and on the vertical axis we have the relative humidity, and the lower curve tells us that if we can stay below that curve, there will be no risk of mold growth at all. It's too dry basically for mold to be established and grow. So it's somewhere below 80, 77% relative humidity, for temperature around 20 and higher. While it's colder, when it's colder, between 0 and 20, we can accept high relative humidities in the construction because the mold doesn't want to establish when it's that cold. It thrives when it's warm. This is an example of how insulation can be installed in an attic. It's basically pumped up loose fill insulation from a truck. But we have seen a lot of damages in cold attics. Like here we see mold growth and even rot in some of these pictures. So what happens in the attic is that it's getting colder there when you insulate more. There's also been changes in heating systems and less good air tightness. And in one of the investigations we've done in the surroundings of Gothenburg, we've seen that around 3/4 of all the attics do have quite high damages of mold growth. Slab on ground started in the 50s in Sweden, and it was a kind of a new design, and in the design phase the engineers forgot to design for the existence of ground moisture, and we have had a lot of problems with slab on ground, especially during the 70s. Today we can design slab on ground in a proper and good way by using thermal insulation underneath the concrete slab. One of the mistakes was not to understand the existence of moisture in the soil beneath the slab, and what we discussed earlier, the thermal pillar that we have underneath the building makes the soil warmer, and since it's warmer and we have the relative humidity 100% in the soil, we have quite high water vapor concentrations, and that was not accounted for in the design earlier. Another thing with foundations and crawl spaces, especially here, is that we have a time lag since the soil and the ground has quite such big dimensions and high heat capacity. There is a lag in temperature, so during the summer it's rather cold in the soil, so the coolness from the winter period is still there. And on the other hand, during the winter it's relatively warm because the summer heat that has been stored in the ground makes it warmer there. But since during the summer and early fall it's quite cold inside the crawl spaces, since you contact with cold soil, and the outdoor air is filled with moisture. During the summer we have as much moisture as possible in the outdoor air. It comes in to the crawl space by ventilation, and the relative humidity increases, and sometimes we get condensation, as in this picture. So we have a constant high relative humidity in the crawl space during the fall period. And as we know now, the mold growth will have a perfect condition there, both quite high temperature and high relative humidities. And here we have some pictures with really severe rot damage in the crawl space. Design of building envelope. The picture to the left here shows a picture that was built around 15 years ago, south of Gothenburg, one of the first passive houses in Sweden. It has a very low energy consumption, of course, and it's proven to be working very fine, the construction. So what we like to achieve is, of course, good indoor environment, energy efficiency, good durability, and we're striving for building sustainable buildings. What's important to think about is, in terms of building physics, to account for the heat, air, and moisture transfer and the different conditions they will cause. Especially when you're changing constructions or you're changing the use of the building, using it for more people or moving it to another climate or accounting for changing climate. Then it's very important to make a proper risk assessment, and there are tools to do this. Thank you very much.